Okay, so I'm back now. I will show you these answers. Unfortunately, you're not in front of me, so if I made a mistake, we're not going to catch it. You're going to catch it, and just understand it is a mistake, but I've checked them a few times. So we have a base count here of 12 base pairs, 20 base pairs, and 25. You can see that we get 20 and 20 here. When that happens, what you do is this. You make the line darker, okay, because it's going to be extra DNA. So this indicates that you've got 2 strands of 20 base pairs, and that would show up in the gel as definitely darker because you've got extra at that point. All right, down here, ignore this highlighting here. So I came up with 8, 20, 20, and 9, 12 on the bottom, 20, 20, and 5. Okay, and then over here in lane 3, I desperately looked for double A's here. I think this is correct. So 27 and 30. 26 and 31. Okay, that's what I got. So if we're going to put in lane 2, we have an 8, a 9, a 5. So I'll take care of this like this. Okay, so we've got 8. So you guys would have an 8 in this area. We said that's about an 8. All right, a 20, again, easy. All right, another 20, so we darken that. A 9. All right, a 12, another 20, so this would be super dark because we've got 3 strands at 20 base pairs, and then a 4th strand at 20 base pairs. So that would appear as a really dark line on the gel. And then we have a 5. Okay, so that's lane 2. With lane 3, you've got a base pair count of 27, so that would be all the way up here. Okay, a 27 and then a 30, so do your best just to get pretty close to that. And then 31 is even above 30, so we'd have another little line up there. And then we'd have a 26. So everything is in this area, okay? That is the end of the homework being taken up. Now, I just want to show you one thing here because I mentioned to you guys that we have blunt ends and sticky ends. So some species of bacteria will cut a blunt end. So in other words, when they're looking for their recognition site will do this. Okay, so this is SMA1. So what it does is it cuts after CCC, between CCC and GGG, and because that's palindromic, you're always going to get these things called blunt ends. So you have 3 on one side, 3 on the other, and these guys are not as useful in terms of they've learned how to use them to some extent. And that's because you want as many bacteria as you can get in the digest, because the more bacteria you get, the more cuts you get. The more cuts you get, the more insulin, for instance, that you can put into this bacteria. So they have learned to use these, but we know that sticky ends are the way to go. These guys are the easy ones. So bacteria that cut, when they cut and they leave this little end hanging, okay, that's called the sticky end. And when they cut and they sever that, what makes it easier to do is actually attach your gene to this section here, okay? Blunt ends don't accept genes as well. Sticky ends do. So that's why I gave you this picture here, all right? This is truly how we use these guys. If we look at EcoR1 and it's cutting after the G, so there's our GAATTC sequence and the sequence on bottom. So when EcoR1 cuts that, okay, it's going to make sticky ends. So this is our bacteria, okay? Now let's say this is our human insulin. So this is our human DNA, okay? And it's got the insulin in it. So we get EcoR1 to come in and cut our DNA, okay? And look what it does. It has these sticky ends. So these overhangs are extremely useful. So I know this is yellow in the diagram. My printer is printing it pink because I must be out of yellow. So human is yellow, okay? And bacteria is blue. I'll just leave that as blue. And then when you combine this, okay, so here we go. Here's our bacterial DNA up to this point. That is this. And then we take our gene for insulin, our human insulin, and we combine it into this. Look at how nicely they can accept each other. We're going to have hydrogen bonds forming here, okay? So we've got our hydrogen bonds forming because of that overhang. It nicely comes in. It would be much more difficult for that to happen here, okay? Because there's nothing for it to attach to. So you don't have this little overhang. where the DNA can come in and attach. And that's what makes sticky ends more useful.